Welcome in Cairo. Now we are going to learn the first chapter of physics, which is waves. Let's start by the first part. Overview. Many of us enjoy watching waves on the surface of water. When you throw a pebble in water, when you throw this pebble in water, it is a source of disturbance. So we'll see the waves spreading from the center of this source. After that, we have here waves. As you see, here we have a model, we have a short video for these waves. What's meant by waves? Waves, they are disturbances. Waves, they are disturbances that spread and carry along energy, as you see. Here, the waves spread in this direction, as you see. So, waves here are not only water waves. We have many types of waves. We have sound waves, we have radio waves, laser, light waves, many sources of light. So, waves, as you see here, we can hear the announcer say here the radio station for any Cairo channel. That's for example. What else? Here we have also the mobile. If you have a mobile, this mobile also has an electromagnetic wave. This electromagnetic wave can be changed to, as you see here, into electric signals, and these electric signals can be changed into sound waves. So if you have a call on the mobile, the sound changes first to electric signals, then these electric signals changes into electromagnetic waves. After that, these electromagnetic waves changes into electric signals and into sound or for image. That's for an introduction or overview for the waves. Also, we have here the mechanical waves. Here a type of these mechanical waves. These mechanical waves needs a medium to propagate. It needs a medium to propagate. It doesn't propagate in space. It doesn't propagate in vacuum. This type of mechanical waves. Mechanical waves need or require, of course, a medium to propagate. Also, it needs a disturbance. This disturbance transmitted through the medium. Also, these mechanical waves need a vibration. This vibration, vibrating source. This vibrating source, all of these are the conditions for the mechanical waves. But the electromagnetic waves don't need a medium. For example, we have light waves. We have light wave, laser. Okay, these examples for electromagnetic waves. Also, we have here many examples for the mechanical waves. We have here the pendulum. We have also tuning fork, a guitar, and here a pop or plum. This pop attached to a vibrating spring, or it is called UU. Of course, as you see, the mechanical waves require vibrating source. It needs also a disturbance. It needs also a medium that carries this vibration. That's for the mechanical waves. There are many forms of vibrating sources, as you see. Okay. After that, we have very important definitions. These definitions, let's start by the displacement. What's meant by displacement? Displacement is the distance. Is the distance away from the rest position. Is the distance away from the rest position at any point. But if this distance is maximum, it is not a displacement. It is called the amplitude. So let's start by displacement. Displacement is the distance. Displacement is the distance of a vibrating body at any instant. At any instant, away or from its rest position, from its original position or its equilibrium origin. This displacement is a vector quantity. That's for displacement. What's about amplitude? Amplitude, it is the maximum displacement. It is the maximum displacement. As you see here, displacement also this displacement, but if the body stops at this point, so from this position to this position, it is called amplitude. It is called amplitude. So amplitude is the maximum displacement of the vibrating body. Maximum displacement of the vibrating body. Okay, so if this distance between 2 points, one of the 2 points, its velocity is maximum, but the other point, its velocity is 0. Maximum where? From the original here, but the velocity is 0 where? At the final point here. So it is called amplitude. Also we have complete oscillation. What's meant by complete oscillation? When I can say this oscillating body is done a complete oscillation, makes a complete oscillation. When the vibrating body passes through a point twice successively in the same direction, we can call this oscillation a complete oscillation. Simply. So complete oscillation, it is a motion of a vibrating body through an interval of time, through an interval between the instants of passing by one point twice successively with motion in the same direction, and same displacement. And these points, of course, they have the same phase, and same phase means, yes, they have the same velocity, same displacement, same direction. That's for the complete oscillation. What's about the frequency? Frequency, we give the symbol nu for the frequency. How? What's meant by frequency? Frequency means number of complete oscillations. If we have a vibrating body, such as a rubber band, and this rubber band is fixed on a wooden table, then we stretch, we pull the rubber band, it makes a number of vibrations. The number of complete oscillations, the number of complete vibrations made by the vibrating body in 1 second, this definition is called for frequency. It's called for frequency. So frequency is the number of complete oscillations made by the vibrating body in just 1 second. That's for frequency. What's about the simple harmonic motion? Simple harmonic motion, it is a vibrational motion in which it has the simplest form. What's about the periodic time? Periodic time is the reciprocal of the frequency. Periodic time is the time taken by the vibrating body to make one complete oscillation. So periodic time is the opposite of frequency. If the frequency, we can calculate, of course, we can calculate what? Calculate the number of complete oscillations in 1 second. But for the periodic time, we calculate the time taken for the vibrating body to make just one complete oscillation. And as you see here, it is a simple harmonic motion. For example, what are the types of waves? We have 2 types of waves, which are mechanical waves and electromagnetic waves. Mechanical waves, as I told before, they need a medium to propagate. But electromagnetic waves don't need a medium to propagate. They can spread, they can propagate in space, they can propagate in vacuum. So mechanical waves is a disturbance that propagates through medium only, such as water waves, sound waves, and any waves needs a medium to propagate. These waves is called, yes, mechanical waves. What's about the electromagnetic waves? Electromagnetic waves is a disturbance that don't need a medium to propagate, such as light waves, laser, X-ray, ultraviolet, infrared. But for the mechanical waves, the medium particles vibrate. Maybe the vibration in a perpendicular position or parallel to the propagation direction. That's for the mechanical waves. But for the electromagnetic waves, it needs 2 fields. One of them is magnetic field, but the other is electric field, and these 2 fields are perpendicular to each other. So here electromagnetic waves, it is produced due to the vibration of electric and magnetic field. At the end, I hoped to understood this part very well. Follow us in the next part. Thank you.